Hello guys, welcome to Bright Future YouTube channel. My name is Nomsa Mashaba and today we'll be doing physical sciences mechanics. We'll be looking at the normal force and the gravitational force. Before we can get into today's video, if you haven't subscribed, please kindly do so. Also share, like and comment the video. Okay guys, let's get into today's topic. Okay guys, let's talk about the normal force and gravitational force. Okay, normal force, this is the force that a surface exerts on an object on top of it. And then, so recall from previous lesson, we talked about you pressing your hand down on the table. Whenever you do so, or even when you just simply place your hand on the table applies an upwards force on your hand. This force is called the normal force. So this force always acts perpendicular to the surface. For example, when John plays the ball on the ground applies an upwards force on the ball. An upwards force on the ball. This is the normal force. This is the normal force. This is exactly the same if maybe, let's say, the ground was inclined at an angle theta. The ground, the ground was inclined at an angle theta, like this, and our angle is theta here. So the normal force will still act at an angle of 90 degrees upwards. The normal force will still act at an angle of 90 degrees upwards, like this. Which is Fn, the normal force. Okay. Sorry. Let's now move on to gravitational force. Gravitational force. The gravitational force is quite simply the force of attraction that the Earth exerts on an object or near its surface. You have experienced gravity each and every day in your life. This is what keeps you from floating on Earth. The gravitational force is also known as the weight. This force always acts directly downwards towards the center of the Earth. This is why when you throw something up, it's going to come down. Let's look at the following examples. For example, again, let's take John's ball. When John's ball is on the ground, it is also being attracted straight downwards towards the center of the Earth. So like this. it's been attracted downwards towards the center of the ball, which is FG. And let's say, for instance, John's ball is now on an incline. Okay, this is our incline, then this is John's ball at an angle theta. This is angle theta. The gravitational force still acts directly downwards the center of the earth. So the gravitational force still acts downwards to the center of the earth. This is our FG. However, very interestingly, in this case, the gravitational force is made out of components. This means that a certain amount of gravitational force acts in the perpendicular manner against the slope, and a certain amount acts downwards the slope parallel to the slope. This force that acts parallel to the slope will cause the ball to accelerate downwards, and it is called FG parallel. So the force that will cause the ball to accelerate downwards, it's FG parallel. So this is our force. FG parallel. I hope you can see, guys. Okay. FG parallel causes the ball to accelerate downwards. Okay. And then the force that acts perpendicular to the slope is called FG perpendicular. Okay. Our FG perpendicular X perpendicular. Okay, it should be perpendicular to the slope, so it will be like this. This is our slope, and then perpendicular will be like this. So this is our FG perpendicular. Excuse me. And hope you can see that FG perpendicular would be in exactly the same line the normal force acting on this ball would be. Like, FG perpendicular is in the same line as our normal force. Our normal force will be in the same line as FG perpendicular. So let me find another pen. This will be our Fn, our normal force. So yeah, and these two forces will be equals to each other. That's why the ball never falls into the slope. Again, the angle between FG and FG perpendicular, this angle. Let me find another color pen. Okay, this is the angle I'm talking about. This angle is exactly the same as this angle. So since that is the case, excuse me, sine theta is equals to FG parallel over FG over our normal FG. So if you multiply by FG on both sides, this will give us if we multiply by FG both sides, it will give us FG parallel is equals to our normal FG sine theta. This further equals to the mass times acceleration due to gravity times sine theta. So this further becomes FG parallel is equals to mass times our gravitational, our acceleration due to gravity, which is G, times our sine theta. Okay, and then let's move on. Okay, and then let me use another color. Cos theta. Okay, cos theta is equals to FG perpendicular divided by FG. Okay, which is equals to FG perpendicular divided by FG. So again, if you multiply with FG both sides, you will get FG perpendicular is equals to FG times cos theta. So you are going to get FG perpendicular is equals to FG cos theta times cos theta. Okay, and then this is then equals to mass times acceleration due to gravity times cos theta. So FG perpendicular is equals to mass times gravitational force, our acceleration due to gravity, times cos theta. Okay guys, there you go guys. These are the two formulas you can use to calculate the parallel and the perpendicular component of the gravitational force. Okay guys, I hope you understood today's lesson. If you haven't, as usual, please comment on the comment section below. Also guys, if you haven't subscribed, please kindly do so. Also ask your friend, share this video with your friends, ask them to subscribe, like. Guys, that's it for today's video. Thank you guys for tuning in. Until we meet again, stay blessed.